Sure. So a little bit of background. This is a paper that's going to be presented at the upcoming Museums in the Web conference. I'll be finalizing the paper next week and can circulate that. So this is a draft slide deck. And so I'm happy to have sort of a conversation around it. I'm really trying to make these things a little more colloquial. So I'm going to talk a little bit around the research, because as part of this is part of Pro Seminar. I think it might be helpful to also sort of talk about some of the limitations of this, what happened here. OK, so a little bit of background. For those of you who don't know me, I spent most of my professional career doing training and development of best practices for 2D digitization. Well, we just called it digitization then, because that's all it was. So how do we take photographs, newspapers, manuscript documents, slap them down on a scanner, and turn them into a digital document that we could then display and distribute via the web? More recently, I've been watching the developments related to being able to do the same kinds of things with cultural objects, but scanning in 3 dimensions. And this is also tied in with the emergence of 3D printing, people's interest in things like maker spaces, and how all these things are coming together. But I'm trying to build on that experience of 2D digitization. So the focus of this is going to be more about digitization right now, rather than what we do with all the stuff once we digitize it. So part of that story is this nice little graph. I discovered, and this is sort of part of this colloquial part. I discovered as I was writing this paper that Mona Hess, who's over in the UK, just in this, I started this stuff earlier this year over the summer. She just did her dissertation in like September or October and made it available, and covering a lot of the same ground. That's great. Now I can use this really nice chart, because she's actually been doing this stuff for a little bit longer time and has been tracking the cost of what it would take to do a 3D digitization project, and sort of also the availability of this stuff for museums to use it. So it used to be, right, you needed like $500,000 or more to get a laser. And right, I can channel Joe Futrell and his fascination with lasers, and really expensive equipment. Do you know Joe? I don't know.
That's the whole, it's a joke. Everybody, yes.
OK, everybody, an old colleague from Illinois. Anyway, old as in I knew him before. So anyway, the cost of these equipment has come down, and also the diversity of methods we can use for 3D digitization has increased. Used to be that, right, you needed lasers and a particular way of doing it. Now we can use off-the-shelf digital SLR cameras and a bunch of other tools that now the cost is getting closer to $1,000. Now, that's not cheap by any standard, but this is about when I first started getting involved in 2D digitization. That's what, you know, a top-of-the-line two-dimensional scanner would cost for the kind of projects that we were doing. So now we're talking, it's in the realm of feasibility. So I distributed a survey, went out to sort of the usual people, MuseumL, which is a listserv of museum professionals, the Museum Computer Network, the American Association, or sorry, the Alliance, American Alliance of Museums, Media and Technology Group, which has a lot of the same. Oh, did you miss that part? Yeah. My friends here at iDigBio were very helpful in getting the word out about the survey. Museums in the web community using some of their social media stuff, Twitter, and also the Society for the Preservation of Natural History Collections, or SPINACH. Primarily focused on North America, but because I was doing it on social media and some of these other places that have an international audience, I did get some responses, mostly from English-speaking places like the UK. So, who responded to the survey? One of the things I'll talk about in the next slide is a little bit about the survey fatigue that happened. But at least initially, I had 48 more or less complete responses. And you can see most of them are museums, libraries, and archives, because I am trying to look beyond just sort of museums. The thought is like, oh, well, of course museums have 3D objects. Why would I even include archives? I'll show you some examples of why in a minute or two. These others are often sort of collections, particularly of paleontological collections or other natural science collections that are associated with a university or research institution, but they felt that they didn't fit into some of these categories, even though some of them, when I look at what they describe themselves as, I might lump them in, but they decided to self-identify as an other. There's like 35,000 museums in the United States. I got about 50 people to respond to the survey. So there's a fairly small number of respondents. And there's a pretty significant survey fatigue. Of the 48 people that sort of completed the initial part of the survey, by the end that had dropped down to 13 completed surveys. But they're fairly interesting. This was another project that I had tried to get some funding to spend a lot more time on this, but couldn't get the funding. So this was a little bit of a wing and a prayer in getting this out last summer. But it's been really useful in sort of at least doing some exploration about what's going on out there that I'll talk about at the end about where I'm going next. The really interesting thing, though, is that there were very few art museums or historical type organizations that replied to the survey. And I know there are some folks out there that are at least doing some educational kind of oriented activities. I don't know whether that's sort of like the right people just didn't get the survey invitation, or whether or not they're thinking about this as a sort of systematic kind of digitization, the way I was describing it in the survey thing. Yeah, ask question.
Sense of where they dropped off?
Yes, and you'll see, I have the numbers as I go through, and you'll see there's a couple pages where, a couple phases of it, because the questions were kind of clustered around certain kinds of things, and you could just see people sort of falling off at certain points. There were, in some of the things that where people didn't complete the whole survey, they did sort of indicate that like, oh, we're just getting started on this and I can't answer these questions at all, because it gets a little bit technical, and I'll show you what we're talking about in a minute. Also, because there were some of these little research collections that were around, a lot of the people who did respond are relatively small kinds of, oh, all right, now I see what's going on here. This was supposed to be like 10 to 20, and it changed it to June 10th. Thanks, Excel. Yes. One of the reviewers of the paper said there was something wrong with it, and I was looking for what they were talking about, and now I see it. Okay, so it's a relatively small staff size of organizations, and also mostly fairly small in terms of budget size. So I don't know what quite to make of this, but at least tells us a little bit about who is at least exploring 3D at this point from the survey respondents. So why are they doing 3D? Most of the people, this is some more qualitative kind of open-ended questions that were in there, so I don't have real fixed numbers. Why were they doing this? A lot of these places are looking at doing research documentation, conservation concerns. So one respondent has a costume collection. Well, you really can't go handling textiles all the time. You can't necessarily provide access to researchers. If you just put up a two-dimensional image online, you can't see the details of those costumes. So what they're doing is digitizing it and providing it in 3D so that you can rotate and look around and stuff like that. And they're also modeling it so that then you could actually now sort of with motion capture stuff, like if you've seen the way they, they're animating people in movies, they could then take this historic costume and then map it on to a model or something like that, and then animate how that costume would move and flow and stuff like that. Sometimes hard to do with historic materials. Lower down was sort of public access to collections and specifically educational outreach activities. In part, I think, because of the help from my iDig Bio folks, the largest number of objects are these sort of nature facts. So, right, fossils, herbarium specimens, other kinds of biological specimens, followed by three-dimensional artifacts, so, right, things that people make. Less so historic archaeological sites and structures, and then plans, drawings, and other 2D resources. And again, that's a sort of interesting example from archives that I'll show you in a second. And these are the number of objects that a particular organization is scanning. Right, so this is also a little bit an artifact of the kinds of collections. If you have a collection of fossils or archaeological stuff, you tend to have thousands and thousands of things. Whereas if you're an art museum, there's only one sculpture of David. So the numbers are a little bit also the kinds of collections that we're talking about. I'm going to go through these to explain a little bit about what they are. But these are sort of what I ask people what it is that they're doing and how they're doing their digitization. So right, the top one is photogrammetry, and then laser surface scan for short range, so smaller objects. 3D modeling using CAD software, 2D resources, structured light scanning. I'm going to explain what all these are. But you can see this is sort of what people say that they're doing right now. Again, this sort of ties into that graph that I showed at the beginning. Photogrammetry is you just need a nice SLR camera and some time. Here you need a more expensive laser, but not as expensive a laser as you would need to do long-range laser scanning. So let's go through these. Photogrammetry is a process where you take a series of photographic images around an object. And the way you do that is you do it in a way that the software, it's essentially an algorithm that looks for registration points across all of these images and then stitches them together in order to create the 3D model. The advantage of this, again, is partly the cost, because you can use just regular cameras to do it, and then you have to have the software, which is pretty easily available, open source kind of stuff. But you also then capture color detail, which you can't capture with a laser. So that's one reason that people are also doing it, is if you want to actually have it look like the actual artifact as a web presentation, this is a nice way to do it. The problem is that because the algorithm is making a lot of interpolations and guesses about what the thing is, you lose certain kinds of detail. And particularly for objects that have occlusion points, it can be hard for the photogrammetry software to figure out what to do with that. So if you have overhanging structures and things like that, the software doesn't know how to build what's behind in the shadow that's occluded by its viewing angle. Right, you can do laser scanning, and a laser scan results in what's called a point cloud. So this is sort of a historic site structure, some sort of temple. They planted a laser somewhere here. I'm assuming all these lines are sort of this is where the laser was. And the laser bounces off and is able to measure the distance to all of these different points. And from that, you can then reconstruct the surface of the object. Again, so this is a long-range scan. If you did it with a smaller, short-range scan, you would do the same kind of thing. Again, what you can do here, again, is capture the surface and the shape of the object and do it pretty precisely, because lasers are much more precise. With photogrammetry, it's a little bit less precise. You get a nice representation of the object that's nice to look at. But if I wanted to do some research and measure the distance between things, it's a little bit hinky because the algorithm gets in the way. Computer-aided design. Why would I include archives in here? Well, this is a great example from Indiana. They have a fabulous collection of two-dimensional drawings of architectural structures. And they were noticing that there was a decline in the use of these archives by architectural students. They're all doing their stuff online. They're not sitting down with a piece of vellum or mylar and ink. They're all now working in 3D CAD software. So the project came up between the archivist for this collection and the instructors in the architecture program to teach the students how to learn the CAD software. They're using the original drawings out of the archives in order to create 3D models. So this is sort of an interesting example of archival 3D digitization that probably could pretty easily be replicated in a lot of places. Structured light scanning. This is, you have a particular device that has a pattern of light, and then a camera is able to detect that. How many of you have an Xbox with a Kinect or some other kind of gaming? Yep, right, I know you do. That's essentially how something like these gaming systems, where you can stand in front of it and move your avatar around, is able to see you. It's using this sort of pattern. It's a little bit hard to see here, maybe from the back. But if you get up close, you'll notice that there's sort of like a pattern to the light. And you're able to then interpret the shape based on how that light gets projected onto that shape. And then CT scanning. Right, we think of this as something we have to do as patients. Our doctor sends us to get a CT scan for medical diagnosis. But actually it gets used pretty widely for fossil and biological specimens. One of the reasons why is that this essentially is a little bit like an X-ray. So now I can also see interior structures that are occluded if I was just doing a surface scan. And it also allows me to measure the density of what I'm scanning. So I could take a rock that has a fossil inside of it, without having to break that rock open and stuff like that. Or a lot of times what happens with fossils is that you dig them out of the ground in the field and you put them into a plaster jacket to transport back to the museum. Well, a normal research procedure would then be that if you wanted to study that fossil, you'd have to break it out of the plaster jacket, which takes time and effort and stuff like that. Or you could take the whole thing, plaster jacket and all, and the structure of the rock that was around the fossil, and put it into a CT scanner, and then extract the bone structure out of that you want. So the example is UT Austin. They scanned an egg, dinosaur egg. They can then see the embryo inside of it without having to break up the egg and stuff like that. The other advantage of CT scanning is also very precise. So if you're a paleontologist and you're trying to understand morphological structures, you can now take very precise measurements and look at, compare those across different specimens. Contact scanning. So you have this little robot kind of arm here, and it's articulated in a way that there's a little pointer on the end. So every time you touch, it measures where that arm is in relation to the base. So that you could do this. This is Cerro Gordo. It's a project, the Smithsonian. They were building a highway, and they were kind of like, whale skeletons, fossils, whatever. We're going to build our road here anyway. So they sent a team down to digitize all of these whale skeletons. Part of the way they did that is using this sort of contact scanning. They did laser scans as well. They're testing out different techniques for trying to figure out which is best for different kinds of information. Again, really precise, but also somewhat time consuming because you got to sit there and make all the contact points. RTI scanning, so you use a raked light, reflective transformation imaging. So I have a really strong light source here, and you can see how it's creating that surface texture that I then have a sensor that's able to understand, and an algorithm that's able to understand and interpret the shapes out of that. Any questions? So those are the basic technologies that are available. And different disciplines are using different techniques, partly based on the research questions that they're asking, but also partly the kinds of materials that they're having. Different methods are better for different kinds of materials. And this is part of what I'm trying to understand, and also trying to understand how maybe a method that was developed over here might actually be useful to other problems over here. Or maybe I get into this because I have a camera and I can do photogrammetry pretty easily, but where do I want to go from that? And what are the best practices across all of these different methods and techniques that may be important to consider when we're trying to figure it out? When we did 2D best practices, we had a relatively more narrow, or at least once it got established, we had a relatively narrow set of technologies to choose from. The kind of sensor that was in a desktop scanner was pretty similar. But then we started having things like digital photography, which had a different kind of sensor. So we had to think differently about what the best practices are. So we have a sort of roadmap for how this ought to go, but we have a little bit more diversity in what's available for 3D right now. So I also asked people what kind of software they're using, again, just to get a sense of what is going on. MeshLab is a particular commercial software. Blender is an open source software. Rhino is commercial. Autodesk. Some of these are 123D is a photogrammetry software. You can actually get it on your phone. So I could take pictures of our director here. So we could have a 3D thing on the wall downstairs instead of a picture. You don't like that idea, do you? And then there's also some open CAD software. So even if I digitize this stuff, I then have to do something with it and manipulate it in different ways. Just like when I take a photograph, I need to work it out. Basically, all of this stuff then gets saved as different file formats. So again, thinking about the best practices here, what are people using? And again, these all have different pros and cons. So PLY and OBJ object files allow me to have that color surface layer, whereas something like an STL, a stereolithograph file, is just the shape. It doesn't tell me what the color of the surface is, or even some of the texture. 3D PDF is a standard that's part of the Adobe PDF standard and works with any Adobe viewer. So one of the reasons why people are using this is because that's what they're using to publish online, because then you don't need any special software to look at these things. It just opens in your PDF viewer. And then, right, this sort of drops off in the end. I'm not going to go through all of these. Just here's a quick view of an STL and OBJ file. This is what it would look like in your editor. So basically it's a polygon kind of structure that maps that surface. And the quality, the resolution, so if we're thinking of 2D digitization, the resolution of our file, it depends on how many of these vertices that we have. So if I'm doing something like a point cloud, I can get a really, really high resolution and a lot of detail. But one of the problems is that's a bigger file, harder to download. And right now, most 3D printers are operating on a more simple level. And it's kind of overkill. So where do we find the balance? Like, what's the right level to be digitizing at? Well, for research purposes, we want it to be really accurate. But if we're publishing them or using them for educational activities, where do we go? So how are people providing access to these things? A lot of people are providing public access via the internet, and then there's this other really big clump of other things. And that's sort of like ad hoc access via researcher request. So I've digitized all my fossils. Somebody knows that I have this collection, and they contact me, and I say, OK, sure, I'll send you over the file. Some use of existing content systems, but one of the problems is that things like Content DM, Fedora, WordPress even, are all optimized for 2D stuff. So often you might be able to take a snapshot and have a two-dimensional image to show for people to browse the library, but then you need to download that three-dimensional file and either open it up in one of those software packages that I mentioned, or you need to start developing an OpenGL plugin for whatever software that you have. And that's sort of the web standard for delivering 3D files over the web. Interestingly, nobody mentioned using something like Thingiverse. Thingiverse is a content management or sort of like social site like Flickr is for two-dimensional images that was developed by MakerBot, which is a manufacturer of one of the printers. So it's a place where you can go and put 3D models for people to download and use. Of course, this is not surprising in some ways because a lot of museums are very cagey about their intellectual property. And when you put things on Thingiverse, it's kind of out there and available to people. But this is where it gets interesting because some of the art museums that I know are messing around with some 3D stuff are doing it on Thingiverse. But it's partly because they're doing it as part of educational activities, and that's why it's up on Thingiverse. So. No surprise here. Longitudinal studies of metadata use is also something we did in the IMLS DCC project that I worked on. Locally defined metadata. If you know what kind of metadata you're even using. So if you watch these numbers have been dropping. So particularly when you get to the metadata part, people are like, oh, metadata? Well, we're using metadata? I don't know. Here's again the overrepresentation, or not overrepresentation, but the high representation of natural science stuff is the use of Darwin Core, which was sort of modeled after Dublin Core, but specifically about specimen data. Interestingly, there's some MARC in there. I think this is partly some of the archival stuff. All those drawings and stuff were done as MARC records and then converted. And a little bit of VRA Core. If people are sharing their stuff online, they are at least using a Creative Commons license to specify the intellectual property rights. Right now, this world of what the intellectual property rights are over a 3D digitized model is completely Wild West. We don't have a lot of court precedents to understand it. The law is really evolving about it. There's a lot of stuff that runs into patent stuff rather than copyright. And we're not really sure what's going to happen here. And also, what does it mean to have a 3D model? One of the things I'm curious about is that over the last 10 years, there's really been a sea change of attitude about using Creative Commons license and openly publishing 2D images from cultural collections. And what I'm kind of curious to see is whether that attitude translates to this stuff. So I was actually pleasantly surprised to see that there are a lot of people who are using Creative Commons. Well, a lot. Half of the 16 people, so 8, are using Creative Commons or some public domain stuff. But there's still a fairly large contingent of all rights reserved, in part because people are still a little bit wondering about what's going to happen here. So just out of curiosity, I also asked them about how they provide access to 3D printers, or if they do provide access. Mostly it's internal audiences. Again, this was a number of the folks that were sort of small research labs affiliated with the university. And they were kind of like, oh yeah, sure, we have a 3D printer for use by researchers and students. But you can't just walk in and say, oh, I want to print out a fossil. So it's mostly internal. There were some number of people who were also providing access to patrons and visitors, but not as many as you might think. I also asked people a little bit about, like, well, how are you evaluating this, right? So if you're going to write a grant proposal, you got to talk about your evaluation plan. So how are you evaluating what you're doing? No solid evaluation plan in place for most of the respondents. At least, again, this was one of the qualitative questions, so I don't really have an N here. People responded to this question by saying, oh, sure, we're doing web analytics. We're tracking the use of who's downloading these things, stuff like that. But not really a formal educational evaluation. One respondent mentioned that they're doing some pilot studies with teachers and educators where they do have a little bit more of a formal kind of plan for studying the impact on learning of these things. But otherwise, this is sort of like wide open right now. I asked people a little bit about, what are the challenges of doing this? Of course, this is always a problem, money. But they spoke about it in terms of institutional support. So a lot of the projects that replied, some people have grant funding, and that's how they're funding it. This isn't really a surprise. This is how we started 2D digitization projects. We went out and got grant money. And because 3D is still relatively new, you can still do that. It's actually really hard to get money to do a 2D, just a straight up, I'm going to digitize stuff. From grant agencies, because they're looking for new, innovative models, and we know how to do 2D now. So, but part of it was also like, where does this fit within my institutional mission? So if I'm going to either devote some time to write grants or even use operational funds to do this 3D digitization, people said that there wasn't really sure about like what the payoff was going to be, or like what the scale and how you're going to do it systematically. So that's partly they're having to justify investigating and exploring some of this 3D stuff because they weren't quite sure what it is. Interestingly, then they still don't have an evaluation plan that might help them answer that question. But again, we're now getting into a much smaller pool of people who got this far in the survey. Hard to find people with 3D expertise. Brand new technology. How many of you have scanned something with 3D stuff? You guys in the back. But actually, how many of you scan something with a two-dimensional scanner? Yeah, right. Now it's sort of like commodity like stuff. It's everywhere. You go to your public library and scan stuff. But not a lot of people, and then also with the really hard problems presented by cultural materials and the need to do it accurately for research documentation or color stuff. That seems like an opportunity. I don't know where we fit as an iSchool in answering that question. One of the other challenges is that it's still a really rapidly evolving technical environment. The hardware software is changing very quickly, right? The cost is going down. New people are coming in the market with different kinds of products. of the stuff that's out there. The quality keeps going up while the cost comes down. But at the same time, that creates a lot of problems for long-term digital preservation. Because there are no best practice guidelines, or they're kind of emerging and evolving very quickly, we're not quite sure, right, how long this stuff is going to be around or how long we should expect it to be around. And this was a problem we had in the early days of 2D as well. How do you set the standards for what you should have for your resolution and color depth and all these sort of things? No one's really sure what to do with that now. And right, because half of those software packages I showed you that people are using are proprietary, that's also a question then about whether we'd even be able to access that data in the future. And so there's another, I think, opportunity for research. So where am I going with this? I currently have an IMLS grant pending, early career grant. Provide me some funding to look at this a little more closely, in part because of the various responses I got on the survey. Right, I have a whole other section in the survey asking people like, well, okay, what's your process for how you go about doing digitization? And most of the responses I got back were, it's complicated. I don't have time for this, dude. So partly what I've built off of that in this grant proposal is to do some in-depth case studies, to talk to people about what the challenges are, what their workflows look like, and some of these things where I got some suggestive answers from the survey, but really need, I think, to sit down and talk to people about what it is that they're doing. In part, I'm hoping that IMLS is attracted by the idea of taking a lot of this experience I had with 2D digitization and trying to translate this ground level research into at least starting to point to where best practices are. Maybe one of the next grants that we could go for is actually starting to convene. I don't think I can answer this by myself. This has to be a community answer to this. So there are funding from IMLS to sort of convene people to get together and start having these conversations. And hopefully this research could lead to who should be having those conversations and what direction we should be going. So right, I'm going to try to translate this into sort of a 3D digitization roadmap to provide some pointers about where we ought to go. Right, and then Marcia and I have had some conversations. This is all that we're doing the digitization because it's cool, it's new, but I don't know if we have a really good sense of like why yet. The research and documentation needs are very clear, but I don't think that those people who are digitizing for research needs have really developed a clear idea of what the pedagogical value of this stuff is. But as I've told Marcia, that's a little bit outside my wheelhouse. So I need to find the right set of collaborators for that next grant. But I think that's a possibility, particularly as this becomes more readily accessible. That's part of the justification for doing some of the 2D digitization was for the educational value of providing access. So that's the end of my official slide presentation as it stands right now. But as Dr. Allen recognized right away, since we're here talking to students, I'm trying to break my ties and my reliance on PowerPoint. So this was made with something called DeckSet. I can show you what it looks like. Basically, it uses Markdown, which is a text markup language, and then creates a presentation out of it. But questions, conversation, discussion? Yeah.
All right, so I have a question about the file format.
Uh-huh.
In traditional 2D digitization, so there's usually a preservation copy and there's access copy.
Right.
So the file format for a preservation copy and for access copy are usually different. And I think for preservation, it's usually TIFF or JPEG 2000. That's like some grade upon standard. And for access, it's usually like probably, I would say, JPEG, JPEG, the regular JPEG for like images, things like that. So my question is, I know 3D digitization is still kind of like a developing area. I was just wondering if the current practices are kind of doing the same thing. If there's like preservation file or copy or like access file or copy?
From the responses to this survey directly, I don't know. My sense in looking at some of this stuff is that this is one of those challenges with the hardware and software evolving so quickly. Oftentimes, how that particular sensor stores the raw data coming in is proprietary to the hardware. And then that hardware and whatever proprietary software comes with it will then provide you these standard formats. But I didn't get a sense from the survey responses about that. Again, I asked the question about sort of like long-term preservation, and I didn't really get a lot of answers about it. No one seems to have a plan in place right now. So this is part of that development, why I feel like we need to start having conversations about best practices for 3D, because no one seems to have an answer to that question. And if it is still very much tied to the proprietary nature of each of these different types of hardware that we're talking about, I don't know how we get around that. Because in part, we're part of that larger marketplace. You know, those are things that are all that coming out of industry, and we are purposing them for use in cultural heritage. Although some of the stuff is actually very much coming out of, right, we're at this weird inflection point where a lot of this stuff was research labs. It was someone in computer science or computer vision developing new techniques and then commercializing it. And so there's a lot of research about 3D scanning of cultural objects that were in the service of that research project. But now as these things are all becoming sort of widely or easily available commercial products with lower cost, I think that we're going to start seeing more museums sort of adopting that technology. So, right, at what point in time do we have some influence over that market and say, okay, we need some sort of archival format for this stuff? Now, that said, a lot of the source data for this is just a bunch of numbers. And it's just a text file with the measurements and the angles and all this sort of stuff. So from that point of view, it's relatively easy. It's a little bit different than sort of like a raster digital image. But being able to interpret all that raw data is the problem.
Yeah, I'm also thinking that because the technology is still kind of new in comparison to 2D, because usually at the beginning, people kind of focus on access and sort of preservation. So once, you know, the 3D technology matures, perhaps there's probably more, you know, I guess, attention, you know, it's kind of to, how to say, attention is going to focus on the preservation aspect of it.
Mm-hmm. Right, and particularly because some of this is coming out of the sciences, and they're using it for documentation and research purposes, where I'm doing a morphological study, and rather than going travel to all these different places, I'm going to take all those digital files and either manually compare some measurements or even algorithmically look across all these different fossils of the same species and have the computer do some comparisons for me. Then you start falling into the territory where you're going to fall under NSF digital preservation guidelines. And there are probably, some of these people already have to address some of those questions. But I hope that some of the stuff I might get in the case studies then is, well, how are you dealing with that problem or thinking about it at all? Mm-hmm.
Actually, that was a really nice sort of lead into the question I had about data management plans and NSF. And so I guess this is more of a comment, and then I'll go to the question, because I think that this is very timely, this research, because the data management plans that are associated with NSF proposals are definitely a discussion point at the tables, and they can make or break whether somebody gets funded. And IMLS has a very similar plan, so this is part of the whole open gov, open data movement of this administration that we just have to hope kind of continue.
Right.
Depending on what the next election holds. I was wondering too, in thinking about the folks you had here, there, and the idea that you have about case studies, if any sort of profile emerged, because I'm thinking in the iDigBio community how all the small collections banded together and are sort of well-versed with small collections network because they face similar kinds of problems. Are profiles of various sizes of organizations emerging out of your responses yet?
Again, I feel like, and I don't know why this is, I don't know if it's partly this is actually some interesting finding, that they often seem to be affiliated with some larger research-oriented organization, like a university. And so maybe this is undermining my argument that this is about to become a big widespread kind of thing. But, right, even the costume thing, that's a project at Drexel. And they have like computer science people there, and it's partly it came out of a computer science set of research questions, combined with that, like, hey, we have this fabulous costume collection and we want to do something with it. So that seems to be like, of this set of people that responded to the survey, kind of an overwhelming thing. What I didn't put in this paper, or in this slide deck, but is in the paper, is I also put these findings in conversation with a survey that Mona Hess also did as part of her dissertation that was also just published last fall as I was writing all this stuff. But it makes a fascinating kind of comparison. So she's focused on UK and Europe with very few North American respondents. But she has a lot of the same kinds of findings that she was particularly talking to people in archaeology that are, again, often affiliated with a university or research organization, but parallels a lot of the findings that I have here about focus on research and documentation, a lot of the same file formats, a lot of the same kinds of technology, distribution, and also questions about quality. So part of her research, she's actually someone interested in computer vision and 3D scanning. So most of her dissertation, it's actually a fascinating dissertation to look at if you're looking for models of the 3-paper dissertation that we've been talking about. And some of the papers that I've been reading out of University College London are really good examples of that. Right, so one paper that sort of came out of her dissertation was the survey. The other part of the dissertation was actually developing some test objects to test the quality of different 3D scanning techniques. And then the third part of it was testing the relationship between that digitization quality and user perception about, like, can you tell the difference between this method or that method, or this quality or that quality, and some user interface things. So it's a fascinating sort of like set of 3 papers. I feel like I've lost where the question was going now.
Oh,
So I feel.
Back to the previous episode. In that episode, we were talking about profiles that may be emerging of your
Yeah.
users. Either is it cutting by collection size or institution type or neither, or it's too early to tell?
I think it's too early to tell. And again, I feel a little bit reluctant because I don't know how much. I have a suspicion that because some of the stuff that went out to the iDigBio community went out through iDigBio, that either that community is ready to have these conversations because they're a little bit further along, or it had some more authority because I had Gil and Deb send those messages out. And like maybe people were like, oh, it's coming from Deb and Gil and iDigBio, so I'm going to respond. Whereas the other stuff was a little bit more cold. I don't know. Maybe my name rec has gone down in the museum community. But I can't quite figure out why that balance is. Like how to interpret that. Is it just that there's more natural science folks doing this kind of stuff? Or is it something else about the way the survey got distributed? So I'm a little reluctant. That said, given Mona Hess's survey participants, which was a little bit different than the ones I had, they really kind of nicely fit together to make a little bit of a big picture. And the fact that there was some correspondence between what I found and what she found was like right when I first came up, she responded to the survey and said, hey, I'm publishing all this stuff right now. I just did this survey 2 years ago, blah, 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 in a nice sort of way. But then it was sort of like, oh, well, actually, this is really great. It's a little bit different, but it lines up in a really interesting sort of way. So, right, if you feel like you've been scooped on some stuff, you got to figure out how to work it to your advantage. Ren?
Just actually met with some anthropology people today.
Here?
They wanted to use, this morning, they wanted to use the scanners and the printers to see if they could start with their collection. And I'm like, oh, it's probably not the degree of accuracy that you want.
Right.
But then we can actually see.
Yeah, so then this is sort of becomes a question of, one of the big questions that I really struggled with, in part because the way IMLS is now doing grants, so for all of you who might be interested in applying for an IMLS grant when you get out in the world, they're now doing this two-step process. You do a 2-page preliminary proposal, and then you do a full 10-page proposal with all the supporting material. One of the questions that came up in the preliminary proposal is like, how are you going to pick these case studies? And partly I, in the full proposal, could then say, well, here's what I found from the survey, and maybe there's some things I can learn from that about who to go talk to in the case studies. And so drawing this line between people who are at a research university and are doing research versus I am a collecting institution, I'm trying to digitize my collection, I still haven't quite figured out where I'm going to cut those two things apart. Because right now it's a little bit commingled in some of the respondents that I have here. But I guess, yeah, I'm happy to talk to people about what they're doing. I had coffee with someone from Classics this morning about archaeological data, so. New postdoc.
I'll send you an email.
Any other questions? No? Well, thank you so much for
Sure.
giving us your time today. We appreciate it.
Oh, that's about an hour. Yeah. Thank you.